And so now we're getting into kind of other kind of questions. I understand that the SM-36 Stalma program should be watched when should be watched for the development of technologies that are going to fly the hovercar.
Mhm.
We wanted to just know, how are you on developing a prototype for the hovercar?
Well, the two projects are kind of tied together from a technology standpoint in the propulsion system. And so, lately we've focused on just finalizing the SM-36 design. It's gone through a lot of different iterations and it has kind of a long history, but we pretty much finished up the core shape and configuration about a month ago. We As a
Cool.
fighter plane, we wanted it to there's some driving factors such as the weapons bay size and that sort of thing. So we finished that up and we hope to have the new images and that sort of thing finished. But part of it is when we're or released. Part of it is the the engine itself for that airplane is a gas turbine engine, and it's a little different because it's not just an engine that can shift between a turbofan and a turbojet, but it has a very large aft fan to it, which is kind of unique. There aren't too many airplanes that have aft fans. The Convair 990 did, and
Yeah.
that's a fan on the turbojet itself. So you have an airplane that's intended to get better fuel economy while flying at speeds under, Mach 1. That's the whole idea. So it can loiter and have long range. And then when you need the speed, you sweep the wings back and you go faster.
Okay.
To do the vertical takeoff version, we're generating electricity using the engine, and that electricity is then used to drive our propulsion system for the vertical aspect. And that's using an inertial propulsion system, which is a mechanical approach to uh, uh, achieving vertical lift or really lift in any direction. So this is really
Okay.
a mechanical system driven by an electric motor. That same approach is what we're using in the hover car. So what the hover car does is it's getting rid of fans and blades, and it's shifting more towards an inertial propulsion system that will allow you to have a directed force and generate propulsive lift without needing air. In the case of the Stelma, that's nice because we can put it strategically in different places in the airplane and allow it to lift vertically. Now, we could, ultimately use this as the main propulsion system, but uh, for just a wide variety of reasons, we've left the jet engine in there, and the
Yep.
jet engine is both providing forward thrust as well as a degree of vectored thrust as well as power to drive the inertial propulsion. In the case of the hover car, it's almost more like a hybrid vehicle where you do have electric batteries, you have the inertial propulsion system, you have electric motors, but you also have some sort of primary generator, which
Okay.
can either be a engine that puts out about 500 horsepower. It could be a rotary engine, it could be a gas turbine, or it could be something more exotic, like a EVO generator or something else.
Mm-hmm.
So you could have a one that uses traditional fuel. You can have one that uses the EVO technology, or one that uses like a radioisotope power source, or some small type of energy generation device. So we're looking at all of those different modes for propulsion, and it also translates into eventual aircraft propulsion. We'd like to phase out the traditional fueled jet engine
Yeah.
with something else. And that something else really gets into the EVO technology.
Yeah.
And it gets into other technologies too that aren't really EVO, that are not at all, but they're other methods of producing energy. So in that sense, the hover car really represents uh, a breakthrough energy product. But it's also, you can prototype it today using like a gas turbine engine to generate the electricity, drive the electric motors for the
Yeah.
inertial propulsion system.
Wow.
Um, so I hope that kind of helps.
Yeah. So how far away do you think you are to public disclosure of the prototype and whatnot?
Well, we've got two neat things happening. We're doing kind of a closed inertial propulsion meeting on the 27th of this month of April to go over all of our different modes.
Cool.
Then we're working on the airframe structure itself. So we're working on producing the airframe, and then we have test beds for the different propulsion systems. And some of that is coming out of the Stelma project. So the HoverCar and the Stelma can come out at about the same time. As a prototype, we're looking at about 1 to 3 years. We'd really like to get a prototype out as early as next year.
Wow.
Wow.
See, and it's not really for us, it's not a super expensive project. It's about a $5 million initiative, but the prototype itself isn't really that expensive. But then you get into, it's about, let's say, $1 million or less for the prototype. That includes all the machinery and tooling and stuff like that.
Yeah.
There's also a demonstration aspect of it, which is really bench testing the different propulsion methods.
Yeah.
All said and done, it's probably about a $500 million project. That's what we budgeted.
Okay.
But there's an FAA component certification aspect of it. There's, that includes a number of different things, including any self-flying technologies that get into it. If we have an artificial intelligence component, so there's a transformation of the project from a product or into a technology into a product. So that's part of it too.
Yeah.
So it's not, I'm not saying, hey, we got to go spend $500 million to get this thing to work. But all said and done, when you add up everything that led to the factory and led to the production costs and the tooling and setting everything up, it's about a $500 million effort.
Okay.
That will be probably funded. We have 2 phases for the program right now. The first phase, we're just funding through the investment capital we're raising through accredited investors and that sort of thing. The other funding, and there is some degree of government funding that gets into that technology too, or customer funding, I should say. The other funding for like the larger amounts to put it in production, that comes essentially from pre-order backlog financing. Like you secure a certain number of orders, it's on the books that you have paying customers, and so you're able to secure, essentially a loan from a bank like Bank of America or Deutsche Bank or something like that.
Yeah.
And you just complete your development and move forward. Technology speaking, there isn't really any technology problems. Part of this whole approach is taking things that have been discussed in the aerospace, defense, and the UFO community, both of them, for 60 years.
Yeah.
And just finally doing something with it. And so this is not the first time we've encountered these kinds of technologies. I've been hearing about them my whole life.
Yeah.
And there are people that I know who have built a lot of different devices that fly, that are unconventional. And so that's part of the reason we're having, this event later this month, which is, it's kind of another opportunity to say, okay, so here's all these different approaches to this same technology. So let's just discuss it and decide which ones we're going to focus on in addition to what we're focusing on.
Yeah.
Yeah.
That's very cool. So is that like a meeting with the board of directors with Stabati that you're talking about?
No, it's really a group of people that we've known for years, and different other inventors. And where this comes out of is, as soon as you mention you're working on something like this, you get all kinds of inquiries and phone calls and emails saying, hey, I've got a device that'll do such and such. And we said, oh, okay, well, how about we all just get together and see
Cool.
which we believe has merit and which don't, and we'll plop them all on the table together and say, well, this is what we're working on.
Wow.
And if you have a device you know, that can be licensed or can be produced or can be used. You know, maybe you have a better approach. I don't know.
Yeah.
No
Wow.
idea. So it's kind of fun.